Okay, so we are going on to radical expressions and equations, and we're going to start with 5.1, just working with radicals. Now, all of this should be a familiar skill from Foundations 10, but we are going to just get some good practice in this first section, so don't worry too much if you are having difficulties remembering what we're doing. So the first thing that we're going to do is we're going to convert mixed radicals to entire radicals, or we're also going to convince them to be entire radicals. So a mixed radical has a coefficient out in front with the radical. In order to kind of put this back in, there are two different ways to think about doing it. So originally, this was in here, and we need to put it back in there. So there is the little index value there. That is technically a 2. Now this index tells us how many times to put this guy back in. So there are two different ways to look at that. You can say 2 times 7 times 7, or you can go 2 times 7 squared. They mean the same thing. So that should result in, once it's simplified, the square root of 98. And if you broke it back down and moved backwards, you could see it would get the same thing. Now with a to the power of 4, square root a, this has a little 2 there again, so this says put this in here twice. So this will be a times a to the 4 times a to the 4. All of these get added together, so it should leave you with a final value of a to the 9. This one here is a little different. It's cubed, so it'll be 5b. I'm just going to rewrite it so it's a little easier to see. 3b squared. So it says put it in there 3 times. So a way I'm going to do that is I'm going to say 3b squared times by 5 to the 3 times b 3 times 1, right? Because if it's power to the power, you multiply it just the same way we would have went a to the 4 times 2, and that would have gotten us the same stuff over here. So now we simplify. This will be the cube root of 3 multiplied by 125 should give us 375b. This is 2 plus 3 to the power of 5. Okay, next set. Radicals in simplest form. So now we're going to go backwards. There are two different ways that we did this in Foundations 10. Those are going to be the same ones that we focus on. And sometimes it's easier to do one way, sometimes it's easier to do the other. So here's what we're going to do. This is the square root of 200. The first thing I'm going to do is I'm going to break it down into a factor tree. I got 2 multiplied by 100, 10 multiplied by 10, 2 times 5, 2 times 5. Now because this is a square, we need to select groups of 2, so let me grab a different color. 1, 2, 1, and 2. And we take one of each of those, just like how we do in factoring by decomp. So then this becomes the square root of 2 multiplied by 5 to give us 10 root 2. Okay. Let's see this one. This is the 4th root of c to the power of 9. So we are looking for groups of 4. So if I think of groups of 4 in here, so that would be 4 root c to the 1 times c to the 4 times c to the 4. So these are groups of 4. So I take one of each of those to come on the outside here. So then it's c multiplied by c, 4th root c, to give us c squared 4th root c. Okay. Now, with this one, we have a couple different things going on. We have the square root of 48 y to the 5. Now, I'm going to break this down into the biggest perfect square that's going to fit in there. Is it 4? Or is it 16? Let me check. 48 divided by 16 works perfectly. So then I know that this breaks down into the square root of 16 times the square root 3 times, this needs to be broken down into groups of 2. So then this would be y2 times y1. So this is just looking at it a different way. So then I can simplify this. Let me get that in right. I can simplify this one, this one, this one, and I cannot simplify this one or this one. So that'll leave me with 4 multiplied by y multiplied by y multiplied by the square root of 3y. So 4y squared square root 3y. Okay? Now, again, that's just a different way of looking at it. If that way doesn't make sense to you, don't worry about it. Move on, do one of the other ones. Always break down into factor trees, whatever makes the most sense to you. And then we're going to go on into adding and subtracting radicals. So this is kind of using the skill from before and adding and subtracting. Now remember, if we are adding and subtracting, they need to have the same base. In this case right now, it doesn't look like it. So the first thing that you have to do is you have to break this down. So this breaks down into 25 square root multiplied by the root of 2 plus 3 root 2. So this becomes 5 root 2 plus 3 root 2 to give us 8 root 2. So because this was the same, we could add just the ones out here. This is like the same thing as saying that I have 5 of something and I want to add 3 of something. This would be the same thing as saying this is an A value. So what's 5A plus 3A? Well, it's 8A. It has to look the same though, so we need to prove that it looks the same. So if we look at this next one, let's break it down again. So essentially, if it looks like an entire radical, you probably need to change it to a mixed radical. So this changes to square root 3, square root 9. This one changes to 16 again, I think. 80 divided by 16. Yeah. So the square root 16 times square root 5. And this one breaks down a little bit more yet. So square root 4 times square root 3. So we rewrite this. So this becomes negative 3 root 3 plus 3 root 5 minus 4 root 5. Remember, this is 2, and these two multiply together to give us negative 4 root 3. We combine, so we can combine here and here, so that gives us negative 7 root 3, and then we can combine here and here, and that gives us negative root 5. Okay? Last one. The square root of 4c minus 4 root 9c. So this breaks down into 2 root c, because you can break it down to the square root of 4 times the square root of c, minus this breaks down into the square root of 9 times the square root of c, so 3, so 12 root c. So now we can combine, and that gives us negative 10 root c. So part of this is remembering your perfect square values, your perfect cube values. So kind of remember that list. Back in grade 10, it was recommended to have at least up to 10 or 15 memorized. But always just have like at least the first couple memorized, I would say. And that will help create ease in these questions when you're trying to find those perfect cubes and squares and quarts that go into these guys. And it'll help you with the understanding of what's going on here. All right, the assignment is at the bottom. If you have any questions, please let me know.